Okay, all of you, a very warm good evening to all of you present here, and welcome to this special lecture, which we'll talk today under the organized by NPTEL, and I'm thankful to NPTEL for giving me this opportunity. And my name is Sudhir Misra, and I teach here in the Department of Civil Engineering at IIT Kanpur. The discussion today, viewers, is the 4 and 50 challenge, the importance of continuing education. It's a slightly different topic. I don't think you would have probably imagined what we will talk about as far as the discussion today is concerned. So having said that, the first question is, what is this 4 and 50 challenge? And since we are talking about continuing education, obviously you get a hint that it has something to do with education, engineering, particularly engineering education. Okay. So now when I talk to professionals who are practicing engineering, whether it is in construction or not, whether it's civil engineering or not, of course, let me also tell you that we'll probably be talking mostly about civil engineering examples, but what I'm going to say is pretty much general and applicable to all other disciplines as well. So when I talk to these professional practicing engineers, let me say that I'm not a professional practicing engineer, I'm wearing a teacher's hat. I hear laments about engineering curriculum in colleges. What they tell me is that in engineering colleges we don't teach this, you don't teach this, and when those people they come and start working for us, they don't know anything, which in other words tells that you don't teach them anything relevant to us. And very often there is a lot of advice that comes to it. They tell us that, well, this is what you should teach. If they are civil engineers, you should teach them, you should teach that. If they are mechanical engineers, you should teach them this or that, and so on and so forth. Now, with all this advice and this criticism that we have, what is the blunt proposition? What is the bottom line? The bottom line seems to be that if somebody studies in an engineering college for 4 years, gets a degree in engineering, what is being assumed is that that particular amount of knowledge that you got will hold you in good stead and suffice for a 50-year career. This 50 is just been kind of a illustrative number. It's just a number. Don't bother about it. What I'm basically saying is that if you start your engineering career, and this whole discussion is about undergraduate education, when you do your BTech or BE and so on, we are looking at the fact that, okay, you may be graduating at say 22, 23, 21, and you work for another 50 years till about say 65, 70 and stuff like that. So now whatever you learn in these 4-5 years, will that be sufficient to hold you in good stead and suffice for a 50-year career? There is a problem with the... Oh, what is happening? Oh, this simply cannot happen. We cannot have a situation where this 4 years will be sufficient for 50 years. What we'll do today is we'll continue our discussion. We'll highlight the importance of continuing education. We'll go through and explain to you this whole exercise of curriculum design. And I do not know how many of you, I could see that about 65, 70 of you had joined at that time. How many of you are engineers who are practicing and how many of you are students? But let me give you some insight into how in an engineering college we do the design of a curriculum. We'll explain the thought process, we'll explain basically the constraints that we have, and that more or less determines what kind of a preparation which we do for you when it comes to those 4 years of education. Then we'll talk about development of appropriate modules for continuing education. We'll talk about leveraging technology for continuing education, and that is what is being talked about a lot these days with so much emphasis on online education, online classes, and so on and so forth. Now let's try to understand what is the college education all about. The college education, the way I look at it, is that one model, if we were to try to think in terms of a process, which is an industrial process, let's say, we take in high school graduates, intermediate graduates who are coming out from there, we impart this education to them, and we churn out graduates. So our graduates are a matter of, in a matter of speaking, our graduates are like our products. And how we shape these products depends on the kind of education that we give, which is partly related, partly not related to the kind of raw material that we have, that is our high school graduates. And these people are becoming useful to the society. So these are the, what is the whole idea of education anyway? The whole idea is that once you complete this education process here, then you go out of our portals and become useful engineers, work ready to work and serve the society. As far as civil engineering is concerned, again, an illustrative example, its evolution of over hundreds of years has made sure that it covers an extremely wide area of scientific knowledge and is perhaps the widest in scope among different engineering disciplines, which means that as far as this education is concerned in civil engineering, we need to tell you and cover with you a lot of ground. And that ground is supposed to hold you in some kind of good stead when you graduate from here and start working. Let me also mention to you that engineering, and particularly civil engineering, is practice oriented. Practice oriented means the whole idea of engineering is to create something, is to create something new, something useful to the society. Civil engineers create roads, they create buildings, they create bridges, they create industries, and so on. They are an integral part of structures like dams, which are useful for power generation, which are useful for irrigation, and so on. So there is something that has to happen at the end of it, which is useful to the society. So there is not, apart from the science that goes into it, and a lot of you, I would think all of you have gone through some kind of an education process in science, engineering science, to understand that yes, there is a science to it, but finally there is a practice. Let me give you an example. There is a science to driving a car or driving a scooter. That okay, you do this, you press the clutch, you don't press the clutch, you move the accelerator, something will happen. There is a science, there is a lot of things that go into it. But there is a practice. Finally, you have to practice it, you have to perfect the art and learn the art of driving. And then you are ready to go. And to drive, it's debatable how much science that is needed. So anyway, let's not get into that discussion beyond a certain point. Please understand there's a practice orientation to engineering. Let me give you an example of where our civil engineering graduates work. And that is what we are looking at. Let's say they could be working for designers, they could be working for consultants, contractors. Designers are people who design structures, consultants are kind of designers, they just kind of have more specialized knowledge. Contractors are people who are engaged in the building of the structures. So they are more builders. And those of you who are practicing engineers would understand that there is a lot of issue and there is a lot of science and there is a lot of experience that goes into this building part. That is, contractors have their own things that they think that engineers must know. Apart from that, our graduates could go into government jobs, PWD, Nirman Nigam, and stuff like that, or they could land up teaching like me. As far as specializations are concerned, they could be working in the area of environmental engineering, structural engineering, transportation engineering, remote sensing, and so on and so forth. And apart from all these streams, okay, there is a whole lot of engineers that finally land up working for softwares, finance, and banking kind of jobs. Do you think that this 4 years of education that is imparted in an engineering college will be sufficient for you to be able to work all over the place here, all over the place here, work with these kind of things, and work with these kind of things? You have your own reasons as far as students are concerned. You have your own reasons, and students have their own reason to say that, well, I don't want to do any of this because this doesn't pay enough. This I don't like to do it. People force me to become a civil engineer, whatever it is. I want to get into finance, software, and so on. But please understand that engineering education per se does not prepare you for this. So you do something of like that on your own, and so on and so forth. So it's not only civil engineering; it's true with a lot of other engineerings as well, other disciplines in engineering. Having said that, let's continue with this example. The profession, that is wherever you work, wherever you land up working. I mean, once you get a job with a campus offer, not campus offer, whatever it is, that company expects graduates to be plug and play engineers. Plug and play, I mean, those of you who are kind of, I don't know how many of you are belonging to the generation where there used to be diskettes which used to be formatted. So depending on how you format it, you could store different kinds of data in it and so on. So nowadays all that formatting business has been done away with, and things have become plug and play. You take a simple device, you simply plug it in, and it's ready to play. All these drivers and so on, the computers have made sure that the computers are able to recognize what device has been plugged and so on. So that part has been taken care of as far as software is concerned, but that is simply not possible with engineers. What they expect, the profession expects, is that here comes an engineer, you graduate in, let's say, April, May, June, whenever you do, you go to a job in July, and you're given a document, you're ready to go. It does not work because the environment of working is extremely diverse. That's what we saw in the last slide. And that diversity in the work environment forces a diversity in the curriculum. And therefore, and what happens as a result of this is that since the curriculum is extremely diverse, there is the depth part of it, the practice part of it, which sometimes takes a back seat. That is not, you are not prepared for it. And that is where the employers have to train you. So as far as civil engineering is concerned, the curriculum includes structural engineering, environmental surveying, transportation, and so on, irrigation, geotechnical. All these things have to be taught. Now, how much of this can be taught in 4 years? Okay. Now, apart from all these things which are traditional civil engineering, and that's why it's an illustrative example, there may be other, I don't know how many of you are from non-civil engineering backgrounds, so some of it may not make direct sense to you, but I think you'll be able to understand what I'm saying. As far as civil engineering itself is concerned, mechanization of construction in recent times, advances in construction methods and materials, advances in contracting systems has added a new dimension to the profession. We would traditionally work with a system where the government, whether it is in the form of a PWD or it's in the form of railways or whatever it is, they were the prime employers or prime owners of infrastructure. They would identify builders to build those infrastructures. So they had a certain form of contracting. Now that form of contracting is changing. I mean, all we have all different kinds of formats. I mean, of contracting, like what they call procurement issues. So if you want to get into procurements, then yes, there are PPP and BOLT and BOT and all kinds of things where basically the designers and the contractors, everybody is coming together to finance projects. So that has actually changed the entire dimension of construction industry. Then there is the need to include modern materials, sustainable construction. Environment has become a big, big concern. I mean, we cannot just keep building. There is this life cycle cost issue. Equipments are being uh, introduced every day. Mechanization is happening. The whole quality and safety issues in curriculum, that is very important. I mean, we are familiar with the fact that there is a quality issue in our construction. A construction which is supposed to last, let's say, for 50 years or 40 years or 35 years, whatever that number is, very often we see that it does not last. There is bad workmanship. So, who is responsible for these quality issues? We face accidents at site. Don't you think that engineering curriculum should cover some of these things? Because at the end of it, it's the engineer's responsibility to ensure that whatever is done at site as far as a civil engineer is concerned, it has certain quality and safety parameters which are met. My question to you, ladies and gentlemen, is what all do you expect us to be able to teach in 4 years? Okay, so it's simply not possible to teach all these things as far as civil engineering is concerned, and I'm sure some of you can create a similar slide for mechanical engineering or aerospace engineering or whatever it is. So it's not possible to teach all that. Given the practice orientation of the profession, one can argue that the exposure to relevant codes, specifications, and test methods for materials, components, and systems should be a part of the curriculum. So, for example, civil engineering is concerned, we talk of cements, we talk of concrete. There are different codes which are used in practice for design, for construction, for quality control. So, we have all these documents. These codes and specifications and test methods, those of you who are familiar with it, understand that they are time dependent. I'm not sure if any of you belongs to a generation where IS 456, which is the parent code, which was the present version that we use is I guess 2000, and we have not revised it for 20 years, but before that it was 1978. But IS 800, a lot of you will be familiar with the fact that a very recent revision took place a couple of years ago, but that's also fairly long ago, and there was a change, which basically what I want to say is that these codes and the codes, specifications, and test method, this part is an extremely important part for a practicing engineer. You cannot go to a consulting company and say that I'm not familiar with IS 456 or IS 800 or IS 383 or whatever it is. They will say, I mean, what has the college taught you? I mean, don't you know that cement has to meet certain requirements? You say, well, I don't know. So then that is where the problem is. So, but the point is that if we get bogged down with this codal kind of provisions, which are time dependent, if I teach you the codes for today, please remember that in the 50 years that you are working, those codes will change. So you have to re-educate yourself. So the codes for the design of facilities and so on, they are a thought process in the sense that the steel structures, concrete structures, there's a very different type of thought process involved. The two materials are different, the construction methods are different, and so on. They are time dependent. The provisions change with time. With an education of 4 years, we want to work for 50 years. Now that is simply not going to work. And this is the 4 and 50 challenge. So my take on this matter is that, okay, how do we accomplish this? Because at the end of it, it is our responsibility in engineering colleges. I'm at IIT Kanpur, and a lot of you are probably teaching in some other college. Some of you are studying in different colleges. You also, those of you who are studying, also may have a reservation, or you may have a thought that, okay, why are these guys teaching us this if they're not going to be relevant? Why are they not teaching us something which is more relevant today? But please understand that we have our own thought process and we can talk about it separately. So let's continue from here, having defined the 4 and 50 challenge. This picture here is that of a medical college and a hospital. Those of you who have some relatives, or say your brothers and sisters, father or mother perhaps, who's a doctor, you would understand that any medical college worth its salt has a hospital associated with it as part of the education process. From the medical education, we should learn this very, very important requirement, a very, very important dictum, that there is a functional hospital attached to it. Students need to attend patients under a guiding doctor. I mean, I don't say that a third year student there starts prescribing medicines and so on. No. There is a protocol, I'm sure, where their professors who are also practicing doctors. We as professors of engineering are, I won't say seldom, but most of the time, we are not practicing engineers. We are not engineers who are responsible for constructing a road or making a car and so on. So we know how to make a car perhaps, or what goes into making a car, or what goes into making a road, but we are not practicing engineers. Now these teachers in, as far as the medical college is concerned, they are also practicing doctors. Once they get in, once these teachers are teaching here, they have the teaching hat. Then they take these students to the hospital. Whether they take them directly or there is somebody else who's teaching them there, which is fine. They try to handhold their students in noting the history of the patient, noting the symptoms, trying to understand and make a comprehensive judgment, making a diagnosis, and so on. Coming back and having a feedback into the education system, you go to the hospital, learn something that okay, this is what I saw in a patient. You come back and ask your professor here in the engineering college that well, what you taught us was this, but when we went to the hospital yesterday, this was the one patient, this was another patient. How do we do this? So that kind of discussion which relates these two keeps on happening here in the medical college as part of medical education. Now contrast this to a situation here. Of course, I have taken a civil engineering construction site here, but in the engineering college, how many of you or how many of us really know the reality of a site? What goes on in a construction site, what goes on in the shop floor, and so on. Is the happenings here, that is, in the shop floor or on the shop floor at a construction site, how much of it is a part of our education process here? That is a very, very important question that we need to answer and understand for ourselves. Another thing is, which is related to this discussion here, is that when you are studying to become a doctor, by visiting the hospital frequently, you know exactly your workplace. You know that you will be dealing with this environment here once you graduate from here. Whereas if you are studying here, I'm not so sure how many of you have a clear idea as to what your workplace will look like, what kind of expertise will be expected of you, what kind of environment will be there, whether you'll be, I mean, engineering or civil engineering is a very tough environment in the site. I mean, you are working with elements of nature. It could be raining, it could be windy, it could be snowing. I mean, and so on. It could be a remote location which is hundreds of kilometers away from civilization. That's where you're trying to build a nuclear power plant. So that is not known to you. And that is what causes disenchantment, disillusionment. In 3 years, you work somewhere and you say that, well, if this is what it is, I want to come back to engineering college, or from there, you want to go to some other job. So the point is that this is also this discussion here where the practice part of it. See, now you see the practice. You learn medicine here, you practice it in the hospital. You learn engineering here and you practice it in the site or in design or construction. You may do whatever it is. I mean, even here, when in the hospital, there are different kinds of specializations. People deal with patients, some of them don't deal with patients. I don't want to go there beyond a certain point. I'm sure you understand what I'm trying to say. Now, let me just close this analogy with this kind of a diagrammatic sketch. If we have an academic world of colleges, and that's where you are right now, and what our task in this part of the domain is to prepare you for this part of the world, which is employer who's working, let's say, in domain 1. It could be structural design or whatever it is. There could be another employer who's working in domain 2, which is a construction company. Again, an illustrative example from civil engineering. There could be a designer, there could be an employer in domain 3, which is somewhere in between these two, but possibly a little bit narrower. The question is, how do we build these bridges? This bridge, which talks of the kinds of concepts here, making you ready to work with employer in domain 1, somebody has to build this bridge. We should be building it? Possibly yes, possibly no. That's the whole point. Should we building this bridge too? I'm sorry for this spelling mistake. There is a double I here which should not have been there. Bad quality. So for this employer. Now the point is, what happens to the system like this, the bridge 3? Because you are going to spend 50 years in this part of the world, 45, 50 years in this part of the world. You might find that this kind of a domain is not very interesting to you. You want to go here, but in order to go here, or in order to be able to go here, you should be able to have, you need to have a certain amount of expertise. So this is the bridge that you want to build, and you should build it yourself. You are working here and you want to go to this employer, again you have to build your own bridges to acquire the kind of knowledge that this employer needs. To expect that engineering education here will build this bridge to bring you here, that is where the question and the crux of our discussion is, that well, we have to train you here to work anywhere here, and rest of it, these bridges and so on, that is the question where it's going to be built. Okay, so let's move forward and try to say, I mean, I'll skip this slide a little bit because this basically talks about IIT Kanpur and curriculum revision. We do it every 10 years and so on. The basic point is that we want to create in an education system, or when it comes to designing a curriculum, we want to create, or well, as a product, we want to have in our product an educated graduate. Engineering, whether you're a mechanical engineer or a civil engineer or an electrical engineer, comes later. First of all, you should be an educated graduate. You should be an engineer. And finally, engineer of a certain discipline, in that order. So what we do is, in creating engineers with certain specialization doesn't even happen at the BTech level. So we just do a limited amount of exposure to different disciplines, and the specialization part is left to the graduate level. If you are doing your MTech and so on, then you do get into specialization. So for example, if it was civil engineering, you'll get into structural engineering, geotechnical engineering, environmental engineering. Then in those domains, you might get a little more specialized exposure. Now, what are the constraints under which we work? The constraints under which this curriculum is designed are largely in terms of the maximum load. So you have a certain amount of knowledge which should be delivered to the students. Can we load the knowledge? Can we just dump all the knowledge on them and expect that they would be able to digest it, understand it? So what we work on is a principle of maximum load in terms of contact hours, credits and courses in a given semester that is reasonable. So any college, no matter whether it's an IIT or an IT or any college, they decide for themselves what is a reasonable load, whether you should be doing 5 courses, 6 courses, 7 courses. Then there are organizations like the AICTE or the UGC and so on. They have their own ideas, that is, they have their own guidelines. That is what constitutes a reasonable load for effective delivery and for absorption and understanding of the material. Then we kind of come up with the fact that we'll work with a semester system with, let's say, 14 weeks each, not more than 5 to 6 courses in any semester, not more, and as each course can have only 3 lectures in a week, maybe labs. So, and each lecture will be 50 minutes or 1 hour or whatever it is. So basically this part here controls how much material can be delivered in a lecture of 50 minutes, 3 lectures a week, not more than 5 to 6 in a semester, and not more than 14 weeks in a semester, and to complete the curriculum in 8 semesters. So this limits the amount of material that can be delivered over a 4-year period. So that is more or less a constraint, that well, you have only 4 years, 8 semesters, 14 weeks each, and so on. All that you want to teach, whether you want to teach them finite element methods, whether you want to teach them heat transfer, everything has to be accomplished with these kind of constraints. As far as IIT Kanpur is concerned, I'll just quickly skim through these slides. There are what we call institute core courses. There are the courses like science, engineering science, like mechanics of solids or strength of material, thermodynamics, electrical circuits, data structures, statistics, fluid mechanics, technical arts like engineering, drawing and workshops, some humanities courses. Some of all this, what is can be covered as or called the institute core constitutes 23 courses. As far as departmental compulsory courses is concerned, in civil engineering, we work with structural, geotech, hydraulics, and so on. So this is the number of courses that we have, and the total is only 13. So contrast this 13 with respect to the 23 that we talked about in the previous slide. Then we have elective courses. That is, somebody wants to say that, well, I'm going to be a civil engineer with those 13 courses, but I want to learn a little bit more about structural engineering, a little bit more about environment, or maybe 2 courses in environmental, 2 courses in structures, because I want to have a flavor of what goes on in structural engineering. I want to have a flavor of what happens in environmental engineering. So this kind of a thing is done through elective courses. And apart from these departmental elective courses, we have open elective courses where a student, and this is something which each college will have slightly differently. There are open elective courses where somebody in civil engineering wants to do a course, let's say, in machine learning, for whatever reason. I mean, that is why the whole idea of education process is that we should try to let you as students pursue your interest. That's also part of our discussion. So there is a compromise, or there is a trade-off between allowing you to pursue your interests and ensuring that, after all, I'm giving you a degree, or the institute is giving you a degree, or the college is giving you a degree in civil engineering, therefore a certain amount of minimum civil engineering you should know. That is the compromise. So that is the trade-off. In fact, let me also share with you, you can go and look at some of these curriculum in other universities. You will find that Indian education system, by and large, is a lot more straitjacketed. US universities, typically, I would think, though I have personally not studied in the United States, so don't think that I'm trying to tell you something from personal experience, but whatever little I've understanding or reading that I have, is that they give you a lot more freedom. If you want to be a civil engineer, yes, you can be a civil engineer, but if you want to pursue courses in music, they will allow you a lot more freedom, a lot more liberty to do that. Of course, there's a difference between the universities there and our engineering colleges, so let's not get into that kind of debate. So the point is, institute core, departmental compulsory, and then electives. So this is just the credit distribution of this. This is the percentages. So if you look at that, this distribution once again, though the institute core and science and engineering science kind of courses, they constitute about 40% of your curriculum. Departmental compulsory is about 25%. Elective component here is 9, and the open elective is about 12, and the humanities is about 11. So if we combine this humanities as part of institute core, roughly about 50% is gone, and we are playing around with this 50%. Now with this 50%, if a student takes all his courses from the department, that is, he says that, well, I'm going to do all my open electives also from civil engineering or from whatever engineering that he's graduating in, he will probably have about 48% of his education in that engineering discipline. Whereas if somebody says that I'm not going to do any of your electives of the departmental electives as part of the open elective slot, then it could be just about 35% is your departmental education. The professional part of your education is only 35%. So basically, your professional education in civil engineering or mechanical engineering, I mean, give or take a few percentage points here and there, is between 35 to 50%. Now, with that kind of a constraint, now you try to relate this to the diversity of our disciplines and the kind of expectation which your employers have. It's simply not possible to make the two ends meet. Okay. Now with civil engineering, let's add a few things. There are those of you who are kind of trying to be civil engineers or who are already civil engineers know that there are so many skilled operations in civil engineering. There are masons, bar benders, plumbers, electricians, welders, and so on, who are part of civil engineering, who are so much a part of this building process. Then on the process side, there is this whole thing which you've talked about: mechanization, contracts, materials, finance, and so on. So with all this part is almost completely missing from our education curriculum. We don't, of course, there are kind of pluses and minuses. We don't want, or we are clear in our mind that at the end of it, these are skills. A mason should know how to build a wall with bricks or stone and so on. A bar bender should know how to bend the bar in a particular shape, in a particular manner. He should know how to determine the cut length of the bar and so on and so forth. But at the end of it, these people or these skills are integral to the civil engineering education. You cannot be a civil engineer and say that I don't know what is a mason's job. A mason need not know hydration of cement, but he will know by and large that if he does not mix the mortar every now and then, he cannot come and mix the mortar in the morning and that same mortar will last throughout the day. He may or may not know the whole science of initial setting time and the final setting time and so on, but there are things that he would know. So we have to be very careful when we teach or when we engage with these kind of things and try to bring them into our curriculum as electives or as practice oriented courses and so on and so forth. So there's a very vast thing, field which we almost skim through. We mention it perhaps in our lectures, but we just don't have the time to go into it. So to kind of wrap up things, we must understand that college education is general in nature. It does not address specific needs of the different professions. Can you just give me half a minute? So, college education is general in nature. It does not address specific needs of the different professions where the graduates work. So, if you land up working with a designer, or you work with a consultant, or you work in a government job, the requirements will be so different that it is not possible in a college education to cover that ground at all. Plug and play engineers cannot be produced, they will not be available. And this is something which is more to the employers, that please understand that you don't expect plug and play engineers from colleges. The employers can blame the colleges for the bookish education, but the employees too need to understand the limitations of their college education and the importance of self-study. And this importance of self-study is what takes us to this whole idea of continuing education. That is, develop formal, well-defined continuing education systems suiting their specific needs. Now, this part has to be determined by the employers and by the employees. If you're working for a designer, but you want to be a contractor, or you want to work for a contracting company, and vice versa, you need to say that, well, these are the skills that I need to pick up. Okay, and either the employer will say that, well, I have got a bunch of design engineers with me, but I would like them to know a little bit more of finite element, I would like them to know a little bit of a design software. So that is where this continuing education modules have to be built, which takes us to this point that, okay, who designs the contents of these programs? That is, these programs means programs which are dealing with continuing education. That is, when you're on that side of the bridge, remember there was bridges all over the place, the engineering education on one side, the whole professional world on the other side. While you are here, how do we decide, or what are the contents of that bridge 3 especially, let's say? Who designs the contents of that bridge 3 or bridge 4? Okay, how are they delivered? Is there an evaluation or assessment of participants? is a degree associated with the completion of this program? Let me complete this slide and then we'll talk about it. What is the recognition for completing a program? And is the process of registered engineers or some kind of licensing an answer? See, this whole discussion here, I would think that if you think about it at leisure, you will realize that as against college education, where you register for a course in heat transfer or structural analysis or RC design or whatever it is, because there's a grade associated with it, and you do a certain amount of courses and you get a degree at the end of it. Now, whether that same model, where the course content is decided by somebody else, the lectures are to be delivered through online or offline or some kind of mode is decided by somebody else, there is an evaluation and assessment, somebody gets an A, somebody gets a B, this is decided by somebody else, there's a degree associated with it. Should all these rules be applicable to continuing education programs? The answer is possibly no. Continuing education has to come from within. The employers have to feel that yes, we need to educate our employees a little bit more. It does not matter whether one employee got 45 or another employee got 62 in a course in finite element, but so long as they have learned finite element, so that it has to come from within. Is the process of registered engineers, see, a lot of places in the world have this concept of registered engineers. That is, apart from the fact that you do an education in civil engineering or anything, you are also supposed to become a registered engineer. That is, you practice for some time, you work as an engineer for some time, you pick up certain practice related education, and then you write an exam, which is like a licensing kind of a system, which is not a university. Different countries have their own licensing agencies. They license you to be a registered engineer. So, is that the answer? These are open-ended questions. What is the recognition for completing a program? So, do you, as an employee, if you're working, do you think you need a recognition? The answer is a yes or no, because so long as you know what you have learned, you necessarily do not have to have a certificate. Of course, having a certificate has its own merit, and that is what the point is being made. Is a degree or a certificate associated with the completion of the program? Is how important it is? That's a very important question as far as continuing education is concerned. In fact, as far as NPTEL is concerned, they have, NPTEL has been trying to do its own things with the MOOCs and MOOCkit and so on. I'm sure some of you are aware of it. You can look at the website and move forward. Companies and professionals have to find an answer to these questions. Surely academic institutions can be a part of a lot of these solutions. The exact content can be agreed upon and delivered. Surely there are people in the professional, non-academic world who are equally capable of being a part of this education. There are lots of managers in the non-academic world who can surely teach the practice part of it, even the theory part of it, which is required by a practicing engineer. So we all need to pool our resources and come up with those programs. The material can be recorded and delivered online. That's not a big challenge anymore. So let's talk of some examples. A design consultant requires or wants its engineers to be trained in provisions of earthquake resistant design or finite element method or something like that. A cement company wants their civil engineering employees to know more about heat transfer to better understand the cement manufacturing process. Oops. A construction company wants all its engineers to know more about the properties of fresh concrete, especially in the context of ready-mix concrete. Ready-mix concrete is a plant. Maybe there are some mechanical engineers, but the mechanical engineers should know a little bit about civil engineering as far as fresh properties of fresh concrete is concerned. So these are the kind of very simple examples which could be just a few lectures here, maybe a 1 week program, 1.5 week program, to give you some background in these kind of processes. And surely academic institutions and professional companies can come together to design these programs. What should there be an evaluation at the end of the courses? See, as far as I'm concerned, as an educator or as a teacher, I really don't mind either way. If I'm told that yes, here are these 50 people, you please give them some lectures or try to educate them in a certain area. The education process and the evaluation process have to be necessarily delinked. We have to get into this, at least at the level of continuing education. Because human nature being what it is, and I'm sure you understand that unless there is an evaluation sword hanging at the end of the course, maybe you will not take it very seriously because the drive is not coming from within. So that's a matter of motivation. It's up to us to figure out how we'll work with it. Should there be a degree or certificate at the end of certain completion? So these are the kind of questions which we need to answer. Surely a BTech degree cannot be a license for all time. Can there be a series of professional certification courses operated by professional bodies? Can we introduce licensing systems? We talked about it for design, for construction, for inspection. There is this whole lot of things that can be done, and that's where you have to understand for yourself what kind of skills you have missed out in the college because you were not, the college didn't know where you're going to be practicing. So you have to pick up these things on your own. Now, education in the internet era, there are issues. There is information galore. There is a need to discern. You need to pick and choose to create your own bouquets. That okay, this part, this part, this part is what I want to pick up. This part is better covered in this lecture. This part is better covered in somebody else's lecture. Pick up your information, and you're ready to go. Can allow credits for some courses, so that is where the matter becomes a little iffy. There are administrative issues. Can use them for manpower development programs, yes, so that is what the companies have to do. Laboratory work and evaluation remains a challenge, yes, that doesn't happen in an internet education program. Can we have evaluation free education? We talked about it. How to apply quality control concepts in education process? How do we make sure that our graduates have a certain quality? How do we ensure that the continuing education has a certain quality? These are questions that we need to work on and work answers towards together. What is the role of a mentor or educator or a teacher in the internet era? Now that is a very, very important question for us to answer, think about and answer. As far as information is concerned, I don't think there is any topic in the world about which information is not available on the internet. I mean, if you want, I mean, as far as civil engineering, from the civil engineering point of view, that's where I'm more familiar with, whether it's finite elements or whether it's solid mechanics or whether it is soil mechanics, whether it is contracts, a whole lot of information is available. But you need to be able to discern what is good, what is not so good, what is better. Because let me assure you, there are almost outrageous statements in certain courses which are made, and I can, because that's the free part of internet. I mean, anybody can put together a course and put it on the internet, and that's their viewpoint. I'm sure they are doing it in the best interest. It's their viewpoint, but it is sometimes very difficult to explain, understand at some time, and well, certain times it's very difficult to almost defend. Okay, so I would still believe that there is room for a mentor or an educator or a teacher for guiding the students through continuing education. Now let's try to close the discussion as far as we are concerned for the day. College curriculum keeps a fine balance between science, the rationality part of it, and the practice part of it. Only limited knowledge can be imparted in colleges, especially in the context of practice. Colleges also need to nurture and develop faculty. So now this part here is especially for colleges. I mean, at the end of it, colleges also serve as employers. And they need to also make sure that their faculty develops and grows by learning new things, or at least becoming aware of the latest developments in their field of interest. So they have to spare their faculty for this. Employers need to come forward and design their orientation programs. Now, that orientation program is just the beginning part of it. The rest of it is still open as part of bridging the gap. The construction industry needs to grow up and become more professional and take responsibility. Training and continuing education needs to be a part of corporate thinking. Now, this is something which is very, very important. As part of manpower development, our companies in India, they need to say that, well, all engineers or all employees should devote, let's say, 10%, 7%, 12%, whatever it is, time towards teaching themselves. That can be facilitated by the employer, but at the same time, the employees should also understand that they need to upgrade their knowledge. Okay, and that is what is the whole idea of continuing education. And being a teacher at heart, perhaps there are some questions for you. Answers are not to be submitted. It's a more of a take-home kind of an exam. Not an exam. This is just to make you think. How does skill upgradation fit with the manpower development plans of your company? That's more for employers. How many of us, how many of you work with skill upgradation, manpower development? What percentage of time is an employee expected to book towards self-study, and how is such time monitored? Whenever we try to run continuing education programs in our college here, our at IIT Kanpur, of course, right now we are in a little bit of a difficult situation, but we always get the excuse, or we get a response from our engineer friends practicing that, sir, we don't have time. Now, time has to be found. You have to understand. You means, as an employee, you have to understand that you need certain parts. Employer, they should understand that my employees need certain time to study, whether they study on their own, whether they go and work in and do attend some of these continuing education kind of programs in different engineering colleges or different professional bodies. It's up to you, but then that has to be monitored. What is the annual budgetary provision for manpower development, and is it effectively utilized? And that this question is completely more towards the corporate side of our life. That if we say that, well, a company does not invest in manpower development, that is where the company will find it very difficult to grow. Because only if you invest in manpower development means invest in their education, their upgradation of their skills. That's the way to grow as far as the company is concerned. You cannot rely on college education alone. And with this, thank you so much for your attention, ladies and gentlemen. And it's time for questions and discussion. So this is where we end our presentation part of it. And that I'm advised that I should do an Alt tab, and there we go with Alt tab, and we can lower this, I think. Alt tab. Oh yes, there are a couple of questions that some of you have sent to me already. So let me try to get these questions. I think there are a couple of questions here. Let me read those questions and we go with the answers. Now let me see. There is this question from Vempoli Hanif, which I don't know what is the question. I can't see the question. Okay, this is not the one. I don't know. There is a question says this is the question. This is the question column, right? Yes. Okay. So let me. There is. I don't see the question here. So let me move to something else, which is Riaz Ahmad Lone says from Jammu and Kashmir says, how can education sector play an important role reviving the hospitality and tourism industry? Difficult question for me to answer. But then my answer to this is that, well, if the hospitality and tourism with the hospitality and tourism industry, if it comes up with a requirement that, look, these are the kind of courses that we need, they have to find out who are the right people to be teaching those courses. And that's where the education sector comes in, that you try to go to these places. And that's where it's very interesting. Once the industry knows, and the industry had better know that this is what we want our employees to know. I mean, for example, if it was hospitality and tourism, you should know what you want your employees to exactly learn, and then you try to find out the best place to send them for. Okay, so I think that's where it is. So that if you want to revive hospitality and tourism, I think the question is coming basically from Jammu and Kashmir. I think it's a fair question, very fair question all over the place, that the industry has to identify its needs. You cannot the education sector, as an educator, I do not know. I have an idea, but I do not know exactly what is needed. So then we can work out. I can sit down with those people, work out a curriculum, and deliver it. Okay. So let me try to go to the next question, which is by Dr. Manisha Sandeep Bhatt from Vallabhnagar, Vidyanagar, which says, is education now vocational? In education now, vocational training is necessary. Uh, See, there are different levels of education, Dr. Manisha. See, one is if you're looking at, I mean, skilled, we are trying to skill workmen skills, like we are trying to develop welders or masons or carpenters and so on. There, that is what I would say is vocational training. I mean, if I were to call it vocational training, and there's nothing wrong with that. There are a lot of people who are extremely important. They serve a very important function as far as the construction industry is concerned, and so on. I mean, the other people and other vocations also are equally important. So it depends on what is this definition of education. Are we giving a bachelor's degree, or are we giving a master's degree, or we are giving a vocational training certificate? The question is an open question. So when it comes to BTech, because that's what our basic thrust today was, if it is BTech, I all clearly said that, well, vocational training cannot become a part of BTech education because we just don't have the time. But for engineers to say that, well, I'm not trained to be a mason, and I look down upon a mason's job, now that is where the problem will arise. So a vocational training, some kind of vocational training is part of, should be a part and parcel of your education process. So those of you, I mean, those of us, let's say in civil engineering, who want to be practicing the construction part of life, construction part of civil engineering, they have to understand this thing very clearly, that they have to understand, they have to pick up those things on their own. I mean, I am not a skilled mason or a barbender. So I'll have to find the right kind of person who will teach them those things. Well, that need not be a lecture, but yes, there is the practice orientation of it. Okay, so I think we'll leave it there, and let's see. There is one person called Nampelli Stalin from Telangana. Soft skills. Now, soft skills, yes, they are very important. See, that is where some people ask me, or there's a part of general discussion that, well, why should somebody do uh, humanities courses, psychology, communication skills? I mean, why not? I mean, that becomes the basis of your entire career. All the 50 years that you spend there, not that what you teach, what you're going to learn here in soft skills or communication skills. With that alone, you'll be able to survive. But at least that will give you a starting point. That will give you some kind of a window as to what is important there. Okay, so I think I cannot say that this is not important. I mean, important at all. So then, of course, there is a next comment which is from Professor Kurde Mahesh Kumar, which says, great topic, which is the need of the hour. Thank you, Dr. Kudre. Oh, there are lots of questions. Look, how will it finish? Dr. Rukaya RH, which says from Karnataka, how feasible is this continuing education in pandemic? Now, in fact, this to me, Dr. Rukaya, I would think this is a great time to do continuing education, because we are supposed to be working from home, we are supposed to be learning from home, learning at home. We can identify those topics, we can identify courses which you want to pick up, and do online education, educate yourself online. Okay. Uh, then we have Dr. Anish Kumar, who says, no, I don't know what that's supposed to mean. I think there is some kind of communication issue here. Sudhakar from Vijayawada says, good work, sir. Thank you. Adil says, very good topic for discussion. Yes, of course, this is a good topic for discussion. I'm happy that you found it like that. And try to see whatever best you can make out of it, okay? Then there is Chitra Chauhan from Bikaner, Rajasthan. Is it a good option to study abroad? And how can we start preparation to study abroad? I mean, that's a difficult question, difficult one to answer today. Uh, is it a good option to study abroad? Of course, it's a good option to study abroad for the simple reason that if you study abroad, you go abroad, learn a few things in that different culture, and that is part of overall education. See, the finite elements or the technical education in India is not bad. Let me be very, very, very honest with you. What we teach here is very much, it's pretty much close to what you will learn in finite element or in structural design or whatever it is, heat transfer. Whether you do it here or whether you do it in another part of the world, more or less it might be comparable. But there is a work culture part, there is a ethics part, all that is very, very different. And I think it's part of the overall education process. I think it's a good idea. If you can study abroad, you should always consider that as an option. Then there is Sabari Dasan, who says that currently I'm pursuing a diploma after 10th. Is there a way to enter IIT after diploma? Now, I don't think that will work so easily because there are straight-jacketed ways of getting into an IIT as far as your BTech degree is concerned. MTech, yes, there is half a possibility if you do a BTech, I mean, complete your education somewhere. Yes, then there could be a possibility, but that you have to look at from different courses. In fact, see, the continuing education gives you that option that we have to get out of this idea sooner or later that everybody must study in IIT or IIT is a great place. I mean, I cannot say that IIT is not a great place. I mean, I work in an IIT and I know that it's not a bad place to be as far as teaching is concerned, as far as learning is concerned. But there are a lot of you there who could not get into IIT not because you were not good, but for various reasons. I mean, on that day when the exam was held, you didn't feel well, you didn't do too well. So, continuing education gives you an opportunity to learn at any level that you want, at any level that you feel comfortable with. So, please use that option and try to educate yourself. What is the current education? So, with the scenario of COVID-19, I think we talked about it. It's a great time to learn yourself. There's a question from Spurti Saxena which says, sir, my question may be different. Uh, if candidates have exact marks for at least getting required admission, the performance is good and increased recruitment criteria, I think, Spurti, your question is not very clear to me. Throughout first class and 10th onward, then what is the matter? They have knowledge and experience of enhanced skills and continue to resolve the problem. Even if they cannot apply to the jobs, how can they cope with it? Even they cannot apply for jobs. Yes, so now that is a tricky question. The tricky question is that we kind of believe that is where this certification part comes in. That okay, if you a lot of employers, they say that if you have a degree from IIT Kanpur or an IIT or an NIT, then only then you can apply. I think the question is primarily coming from that kind of a view. And that takes you, Spurti, to a question that there is a quality control of education. So what these people are saying, those employers who put some of these restrictions that you have to have this paper which says that you have completed a BTech from such and such a place, people who give emphasis or on that kind of a paper are those people who basically are saying that they have emphasis in the quality control of education at that particular institute or in that institution. So it's like a brand name. See, I mean, if I want to buy a computer, there is an option that I can do a what's it called? You can buy raw material, I mean, the different components and then assemble it. Otherwise, you can go for a I don't want to name computers. It could be Dell. It could be I don't know what all those companies which are there, and then there is always this Apple computers and so on. So when we or for that matter automobiles. So different automobiles, different companies, they have their own brand value. So that is what is the unfortunately the um, reality of life. But having said that, there's always this scope where you can say that, well, I have not got this particular degree, but there is no way that I am inferior or I am lacking in education or lacking in the knowledge as far with compared to those people. And I have picked up those skills on my own through online education. You can always use that, and I'm sure it's going to, I mean, sooner or later it's going to pay off. Okay. uh, Very informative, Nitinjay, thank you so much. Then not applicable goods, Nitin Kothari Selvi. And then there's, please explain this construction management after COVID-19, what necessary skills to develop in the construction management. I think I'm running out of time on this. I don't think we can get into great detail. But since you've raised this issue of construction management, yes, there is an issue of construction management. See, after COVID-19 or before COVID-19 is not the issue. The issue is construction activities finally will have to resume, and will continue. That's at least what my understanding of the situation is. It may take time, but it will surely resume and continue. And the kind of scope in construction management, yes, we direly need trained construction managers who understand construction as different from design. Okay, our education process is highly design centric. So because design is more closer to science and principles of science, management is not so much of science. I mean, there is a lot of practice part of management, and that's where this whole business comes in. So I think we'll have to leave it at that. And what are the necessary skills to develop the career in construction management? Well, I think you can begin with the construction process, try to understand what the construction process is, try to understand quality related issues, try to learn the safety related issues, try to learn the resource management. See, all construction boils down to resource management, management of the raw material, management of manpower, management of equipment, management of money, and whole works. So try to think of the whole process in terms of resources. That was the question. That was my answer to Santosh from Telangana. Then there's Professor Thosar from Aurangabad. Then there's Kranti Kiran from Hyderabad. How to keep a skill component if you are not from a good college like IITs or VIT? How to keep relevant with industry? I work in the IT field, right? Now, uh, this is for Kranti. Now, Kranti, this is very interesting. You are from IT, and obviously, there the situation keeps changing every day. I mean, I think nothing remains. I mean, in fact, civil engineering, engineering in general, I mean, civil engineering, mechanical, these kind of things are a uh, lot more permanent than IT. I mean, with our mobile phones keep changing, our communication keeps changing, our all kinds of things keep rapidly changing. So you need guys do your own uh, efforts to keep yourself relevant in the industry. So you kind of keep learning on the job all the time, and this on-job learning, whether it is only practice or you try to get deeper into it and try to understand the science and the process of that, that is what is the difference between education and just picking up something on your own, okay, by of practice. So I don't think you should be totally concerned with this. Good college like IITs and BITs don't bother about the good college, bad college kind of discussion. Try to understand or kind of think in terms of what is the skills that you have developed, what are the skills that you lack, okay. Amit Jana from Kolkata, he says has a thumbs up for me. Thank you so much, Amit. Jayashree Chakravarti says, is it true? Is it true employers blame the college for bookish education? Of course it is true. You can ask people, they'll say, you teach these guys uh, which we don't need something. So well, I think we'll just leave it at that. Then there's Anthony from Malaysia. Oh, well, I'm happy to hear from you, Anthony from Malaysia. This shows a more international reach. I'm sure NPTEL will be happy to have people from outside India participating. So, but this is the first time that I'm seeing Malaysia being spelled with an SIYA. Anyhow, so what your question is, can I do a PhD where my age is around 40? So, well, there is no bar at all for doing a PhD at 40. I mean, you can surely do that. Some colleges will kind of look differently. They will say, well, how can you enroll in a PhD program, because it has its own structure. But in principle, there's no bar on that. Okay, so I think that's where I leave it. Then there is Manisha says informative. Thank you, Manisha. Then Govind Swami says no questions, please. Thank you. Vinay Mahawat says from Rajasthan, it has been seen that number of students leave BTech course midway due to non-flexible program and ample job opportunities. Yes, so I think how to keep these factors in consideration while program design, especially in the Indian scenario. I I can't. I think I have touched upon some of these things. It's difficult for me to kind of reopen that thing and start all over again. Vinay, I'm sorry, I will not be able to take this question and answer it at least. Vasudevan is an architect from Chennai, says great presentation. Thank you, Vasudevan. Then there is Babji Malineni from Hyderabad. No, good presentation, sir. Thank you. Then Abhita says education internet era. Yes, it is very useful to me. Thank you so much. Thank you so much, Abhita. Zakir says explain PERT. Now that's a very difficult one. I mean, that's coming down to some very nuts and bolts kind of things. Yes, I mean, I think I'll have to tell you what PERT is. PERT means program evaluation and review technique, and it is one of the methods that is used in construction management, especially in the area of scheduling. When you try to understand that, okay, if I have to do these activities, they depend on each other. Now, what is the shortest time in which I can complete a project? So that's where this PERT business is used. How do we implement this? Now that was from Zaki, and now we have a question from Tirupati, which says that how we implement to rural area improve, how we implement to the rural area improve communication skills. Yes, there is. See, now this is a very interesting question. I don't know how to answer it. I think wish we had more time to discuss it sometime. See, India is a very, very diverse country. The fact that we are talking in English all the time doesn't mean that all of us are equally proficient in English. People in rural areas, they have definitely, because of their background, their education in maybe the local language and so on, they may not be so proficient in English, but that doesn't mean anything, absolutely anything, in their ability to learn. Okay, so how do we implement to the rural area communication skills? Now, I think there is enough material available. People in rural areas will have to just work harder, because unfortunately our engineering education virtually everywhere is in English, even though we try to speak a little bit of the local language just to explain certain things, but we don't have very many quality books available. So we can't, I mean, I think NPTEL is trying to do there are some initiatives in NPTEL which I understand, that there is this transcription of lectures in local languages. So those are the kind of steps which are being taken to encourage and to kind of address this question. But I think, yes, Dr. Tirupati, you are right, there a lot more needs to be done about it. Then there is Professor L.B. Roy. I mean, from the email address that is appearing here, it seems, I mean, I'm very happy that you are here, sir. I firmly believe that 10% of the service time should be spent for training. Yes, 30 years. So I think that's what I said, that yes, I am thankful that you agree with me, sir. Then there is Tripurari Sharan, which is how to tackle with the goons type of people who open an educational institution. There is peer pressure on an educator. See, don't ask me these questions. See, with that whole treatment is um, academic, and what I know, or I kind of get a rough idea as to what you are talking about. But see, that is how the society works. I mean, like, the society has to evolve. See, whole idea of in today's discussion, Tripurari Sharanji, was that the professional society, as an engineering community, we have to understand the importance of continuing education, learning ourselves and stuff like that. So the society has to move forward. And I think, I mean, I'm a little more optimistic. Perhaps I would think that, well, this goon type of people who open educational, see, there's nothing wrong with opening an educational institution, but we have to we should not, if we do not know the education process, see, it's like somebody wants to build a hospital. There's nothing wrong with that person building the hospital, so long he does not insist that I'm going to do the surgery or I'm going to do the treatment. He should have the right kind of doctors. Let them do the treatment of patients. Okay. So I think I cannot get into more discussion than that. Tripurari Sharanji, thank you so much for being with us. Dear mentor, thanks so much on watching today's session. My thinking about BTech get changed. Now I have my okay, fine. I thank you so much. This is a comment from a person called Priya Bharti, and this person says, "Thank you so much on watching your session today. My thinking about BTech got changed, and now I'll give more efforts to my study to do better in 50 years." Yes. So try to think of it as an investment. Try to work hard, and wish you all the best. Okay. Then there is Chelamal from Jodhpur says informative. Then there's another question, comment from someone who says that students are, after completing school, they come directly to enter engineering course. Sometimes they don't know about engineering, then they get forcing parents. See, that's right. The parents, how can facing this situation, sir, you are right. Uh, parents also are involved. See, that's what it says. So it is a whole society which is involved. Parents put so much pressure I'm also a parent. I put pressure. Whether I put pressure or not is not the issue, but I know that parents put a lot of pressure on their children that they should qualify the JEE and IIT mein jana hai, and so on. So this, or you have to be an engineer and not a doctor, or a doctor and not an engineer, or if otherwise I think children have to be given a little more free hand, and I think it is happening. And the children know better. This younger generation knows a lot better how to handle their lives than we think that they know. I think we'll have to leave it at that. Then there is, sir, should there be more industry academic interaction? The syllabus is more relevant. Employable. Now, see, you've used this word employable. Yes, that's right. So, employability is a very tricky question. So, now that is where we cannot produce employable engineers. You can forget about it. That's what the whole idea is. The industry will have to accept the fact that the engineers that they'll get from colleges are not plug and play. They'll have to decide their own education program as far as that building the bridge is concerned. Okay. So I think that's what it is. I don't see. I think I've run through all the questions. That's where the questions end. Thank you so much. I think we've had an excellent session. I'm sorry I couldn't hear from you, but I did read from you, and kind of responded to you. And I think we'll like to close the session now. We can do that?
Yes, sir, we can close.
We can close the session. Thank you everyone for being here. Bye bye. Take good care of yourself. Stay safe. Bye bye.